So today we're going to talk about fiber optics. Should be a fairly quick one today. We're going to look at what fiber optics actually are, and go through a little bit about what they do and don't do. We'll talk about some of the options that we have at Stealth, and then we'll go through features, installing it, setting it up, stuff like that. So hopefully by the end, fiber optics aren't so confusing to you guys. So we'll get going in here. Fiber optics are, the way Stealth utilizes them, are going to be a small sensor you can put just about anywhere. The nice thing about them is you can put them in those tight spaces where, let's say you have somebody with a diagnosis that gives them very, very little movement, so they can't come off of their driver control very easily, and when they can, they can't get very far. Fiber optics can get in there in that tight location and allow you to still have a switch of some kind. So they don't conduct any electricity. Nice thing about that is they're not affected by electromagnetic interference, and you don't need electricity all the way wherever that switch is going to be placed. So some of you guys may have been around a little bit, so you might have been involved with some chairs that have had some weird things happen when they get close to, say, power transformers and things like that in the past. Doesn't happen very often anymore these days, but it used to. These fiber optics aren't affected by that, so that's a nice thing with them. So the other nice thing here, they don't require touch. You don't have to physically touch it. Actually keeping it clean and free of touch makes it work better. So the other cool thing is you get a visible red laser, and there's no audible feedback. So no audible feedback is good and bad, depending on the diagnosis, but you do get a laser, so you get a red dot pointed at wherever that beam is pointed, so you know exactly where to touch or where to break, and you get your reaction. So how do fiber optics actually work? What are they doing when you're using them? You're going to have two components here. So you're going to have your sensing head, and a sensing head is essentially your fiber optic cable, and you'll have an amplifier. So the amplifier is where everything actually happens. The amplifier is what generates the light, it's what receives the light back into it, and what causes a reaction. And in our cases, we're causing switch closures. So like I said, the amplifier is what contains light. It's got a receiver and all the electronics in it. Fiber optic is just how you transport and bend that light up to the point that you need it to be shining at. So inside of your amplifier, you've got an LED that sends the light out. It's going to travel down that cable. And what's going on inside of the cable, you've got two fibers inside. They're hollow fibers. And around those fibers is a cladding that is impenetrable by light. So basically light bounces around inside of there until it gets to the end. So either traveling out or back to the receiver, it's just bouncing around inside of there. What's cool about this is it means it's a very accurate sensor. What is bad about that cladding is it can be very fragile if you're not careful with it. So if you bend it, if you crush it, things like that, that cladding gets broken inside of there, light starts to escape and not work so well. When the light hits the end, it's going to be dispersed out a lot like a normal sensor. It's going to form a beam, but it's just not going to spread like a normal sensor. Where if you're looking at sensing area in like a proximity sensor, it's going to look like a cone coming out of there, right? Where this fiber optic, its sensing area, once it leaves, does not expand very much. Whatever the size of the light is that you are shining on, that red dot is your sensing area. If you're outside of that little invisible field there, you're not going to get a reaction, right? So the other cool thing here is the intensity of the light is what's actually causing what's causing the trigger. So a reflection is happening on whatever surface you are shining at. That second fiber is receiving the reflection. So brighter and more consistent the light is coming out of the first fiber, the better it's going to go back into the other one. The bad thing with that is if you're in a really, really, really bright room, or your fiber optic sensor is looking up in the sun, you could be prone to false activations. And then the smaller the light source, the shorter your maximum distance is going to be for sensing reliable activations. So some of the options we have here at Stealth, we're going to have an iConnect version. That's what you see in the picture here. What iConnect is great for doing is you're going to use a fiber optic in this case to cause a switch reaction, and that switch reaction is going to be transmitted into essentially a mono switch. So this would plug in just like every other mechanical switch you have down here. You could use it for mode, you could use it for power on power chairs, things like that. You can use it for environmental controls and communication devices where it works really well, and things like that. So it's available in 12 or 24 volt version. So in its 12 volt version, that's when we're going to use it for everything but a power chair. So if you have a bed or a manual chair with a power tilt, if you've got a communication device or environmental control that's running off of a mono jack, we're going to use our 12 volt version for those. With that 12 volt version, we can give you a battery pack, or we can give you a wall plug that'll help power that. With the 24 volt version, your batteries off your power chair are going to power that version, and we're only ever going to use that on your power wheelchair. The other cool thing with the iConnect version is you get an on-off switch. So let's say you are on a 24 volt power chair. You need to have we'll say a power switch, but maybe you're doing something with that chair. You don't want them to inadvertently turn the chair off accidentally. You've got a separate power switch for your iConnect. So those fiber optics do turn on and off independent of everything else. iDrive also is fiber optic compatible. So with iDrive, we've got two versions that are compatible with it. IDH 503, which we have here on our left, that's what we're going to use on our trays. So I didn't point this out yet, but all of our fiber optics, regardless of its version and part number, we're going to use the exact same amplifier for every one. This IDH 503 is the same amplifier, but this time we don't put it in its own housing. So it's just a bare amplifier. The reason we do that is IDH 503, we almost always only ever use it in a tray. And in the tray, we don't want to make the trays super duper thick or tall. So we keep these bare, and that helps us keep the thickness of the tray down. So you can still put it inside the tray without eating too much real estate. You don't get any power button with this one though. On the IDH 510, this guy right here, we do have a couple of different things going on. So this is iDrive ready. The amplifier is in housing again. Same housing as our iConnect one. You do have your power button on the side, but this time you have a little bit better sensing distance. So on IDHF 510, we use a little bit thicker of a fiber optic cable. That allows us to transmit more light and to receive more reflection. So our sensing distance here is about 6 to 7 inches reliably. You can get a little bit farther than that, but it's going to be fairly unreliable of a sensing. All the other ones that we just talked about are about half that. They're about 3 to 3.5 inches of a maximum distance, while still being reliable. Mounting options. We've got a few options you can play with here. Most of all of these fiber optics outside of a tray are just going to give you a bare fiber optic cable, and it would be up to you to mount it somewhere. These mounts here would give you that somewhere to mount it. So FO 650 over here on the right would be a pad mount. So what's cool about this is if you already have a headrest with a lateral pad on the side, this gives you a nice secure mount with a flex rod to be able to point at somebody's chin or cheek, for example, for mode switch activation or something like that, right? FO660 is going to be another option. It's very similar. This is going to mount off of any of our SU rods, so our swing away rods, and you can basically put this one anywhere. We can also do this version on a flip back hardware mounted off like your backrest. Your IDCH, we can do fiber optics in lock line as well. So that's these guys right here. This works out really well. It holds in place very, very well once you point it where it wants to be, but it still allows you the ability to readjust its position without requiring tools. So if that collar gets in there and just a little bit different that day, and it's not pointed exactly in the right spot, you don't have to go grab the toolbox just to point it right back where it needs to be. As far as getting it in some trays, we do offer fiber optics in two versions of trays. So in the Eclipse tray, we do it as either the IDT 100-1 or 100-2. 100-1 is going to be 3 fiber optics inside of an Eclipse tray. These would be the standard configurations for the trays, but you can specify where to drill these holes and mount the fiber optics. So we can do it on the left or the right, or if you have somewhere very specific you need them to go and know that beforehand, you can tell us where to put them. IDT 100-2 is going to be 4 fiber optic sensors. Same thing here. So this would be your standard. If you don't tell us where they go, this is where they're going to go. You can request them on either side. You can request them all together, spread them across the whole tray, whatever you need to do for that situation. And then our other option would be this FO690 here on the bottom right. That's going to allow us to mount a fiber optic to basically any tray Stealth does. I don't have a picture of the other mounts of this mount flipped around where you can see how it actually attaches, but you have a nice little mount that screws into the tray. And then again, you have your flex rod, so you can point that fiber optic anywhere you need it on that hand. Works very well for somebody using, we'll say, a mini joystick in a palm tray who still needs to have like a mode switch but can't move their extremities very far. So this would give them a good option without eating up another switch site somewhere on their body. As far as customs go with fiber optics, we can do custom trays and custom assemblies with fiber optics. So we can do a wide range of configurations here. These two pictures they just happen to be one that we do a decent number of. So this is a palm tray with either 3 or 4 fiber optics pointed in essentially at fingertips here. So this is one we do on a fairly regular basis. If there's a custom configuration you do need, let us know and we'd be more than happy to see about building that for you. But let's talk about what you guys want to hear about. What can we do and not do with fiber optics? So programming it is where everybody kind of freaks out these days. I feel like fiber optics were a thing people used to do all the time. And now when I start talking to people, they haven't touched them in 5 or 10 years, or they've never seen fiber optics in use anymore. They still definitely have a place and they still work very well. They're super simple. Once you figure out what you can and can't do, they're actually a lot easier than people think they are. So again, we use the same amplifier here on every single iDrive or fiber optic iConnect. So every amplifier you get with fiber optics from Stealth is exactly the same. So this display is going to be telling you a lot of information here. So this little outlight is telling you that at the moment this picture was taken, it was closing the switch. So that mono jack was sending a command to the chair or whatever it was plugged in. LD here on top, this little L light right here. There's also a D just to the right of that. So LD translates to light on, dark on. We'll talk about it a little bit more in depth in just a minute, but basically light on, you have to cover the beam to activate. Like a normal switch, you hit that switch and it does what it does. And dark on is the opposite, so you have to break the beam to deactivate. So if you uncover it, it's activated. Tuning is done with this tune button right over here. There's a couple of ways you can tune. You can also do it with the plus and minus. We'll talk about that in a minute, but it's going to set It's going to set the distance at which activation occur. So technically what it's actually doing is setting your threshold level, which are these green numbers. And what your threshold level is the number or the amount of reflection required to cause that out light or cause that switch closure. These red letters or numbers over here are your incident light level. So these are what is actually being sensed or reflected back into your amplifier. So all this stuff does tell you something. Knowing what it actually tells you helps out quite a bit, though. The other thing I wanted to point out as we go from this slide forward, everything I'm about to talk to you about is actually in the user manual for fiber optics. We put a lot of effort into this user manual to make sure everything you need to know is in it. And to my knowledge, you guys can correct me if I'm wrong, but to my knowledge, this is the only fiber optics user manual that talks you through actually installing and set it up that's left in the industry now. So you do have a resource that is actually pretty decent. So installing it, I always like to start with the box, find a good secure location for that where it won't get damaged or won't tug and pull on the cables too much, right? Pretty standard stuff here. All of our boxes that fiber optics do come in will have some mounting holes or slots for you, and you can mount it however you need to from there, or you can just use some Velcro or poly-lock to lock it in place there. But when you get to the cables, this is where we need to start being careful. So I don't know if you guys have ever seen somebody running fiber optic cables for communications and like cable and internet and stuff like that. Those guys will drill a long hole or bore a hole in the ground, maybe sometimes a mile long, and run cable through there. And to get it through, you'll see guys tugging on it and pulling on it like they're doing a tug of war contest, right? Ours are a little bit smaller, but they handle that load very well. So they can stretch very well. They're good at that. But anything outside of stretching, they're sensitive to. So first thing we always like to talk about is bending that cable. So what we want to watch out for is too tight of a radius. So if you just bend it over hard, you're breaking that cladding on the inside of your cable and causing damage to it. And it's no longer going to work as efficiently and effectively as it should, if it still works at all. So what we want to do is, especially coming out of either end, out of the fiber head or out of the amplifier unit, you want about 20 millimeters minimum before you start bending. If you're less than that, you run the risk of, through vibrations and things like that, this bend ending up on a hard surface and eventually cutting through itself. We don't want that, right? So let it come out straight first and then take a bend. The official measurement here, as you bend, we don't want a radius of more than 6.6 millimeters. And that's to ensure that the cables don't break. And as far as tension goes, like I said, it'll hold quite a bit of tension. It's great at doing that. It'll hold 30 newtons, which translates to quite a bit. So you can tug on it pretty hard. So pulling on is not really a problem until you yank it out of your amplifier, right? Routing options, don't compress these. They don't handle compression at all. If you start to compress your fiber optic cable, it's going to fail really quick. What it does handle, though, is using like a zip tie or a cable tie like we have here that wraps around that cable. It'll do that very well. It'll handle that just fine. It just doesn't compress very well. So keep that in mind, too, while you're routing. If you get it near or in a spot where it could be compressed, say they go into tilt and it gets compressed as they go into or out of tilt, that's definitely going to cause a problem in a hurry. The other thing I like to recommend is loop the excess cable. What it's going to do is allow it to absorb vibration and shock better, but it's also going to ensure that that loop protects the cable from sharp bends and compressions. But as far as excess cable goes, I prefer not to have so much that I even need a loop. So I like to give myself some slack, so if I need to change things up, I still have room to, but I cut the excess off every single time I'm dealing with fiber optics. So every fiber optic cable you get is going to come with a cutting tool that looks just like this. So what you want to do with this, like I said, I like to trim back a lot of cable. Sometimes I'm removing 2 feet or more of cable. I don't like having the loops, but if you need that much excess, definitely loop it. So what you want to do here is this this attachment head here, you want to loosen the top half. Don't twist it so much that it separates from the bottom half here. Just loosen it a little bit, and then the cable will slide in and out. So slide this attachment head back up the cable towards the sensor until you're far enough for you to cut what you need to cut off. You're going to find the smallest hole that it fits in on this cutting tool. There's 3 standard size holes, which are a little bigger. It'd be more for like the iDrive version, and then all the tray and iConnect versions fit into the smaller 2. And one clean, quick cut, you're going to want to cut it. We need that cut to be precise and clean every time. If it gets cut and it's jagged or it's just a messy cut, light's not going to transmit into it very well. It's not going to transmit out of it very well. And those 2 factors kind of amplify each other. So if it doesn't transmit into it very well, you don't get as much reflection, and that lesser reflection doesn't come out as well either. So by the time it's going into the amplifier, it's greatly minimized. So a clean cut is very important here. That's why we also make sure that every single one comes with a new cutting tool. Adjusting the fiber optic connector here is pretty simple. I've seen some guys slide this back and forth until they have a little bit hanging out. Then they will insert it into the amplifier and tighten it down that way. What you run the risk of there is shoving this too far back in there to where it's not out far enough, or the cable gets bent inside the amplifier and you get a bad you get a bad either light in or out coming through that cable. So you really want to just loosen it up, slide it up until that cable is only sticking out about 0.5 millimeter. So I know nobody here has a tape measure on their vehicle that measures 0.5 millimeter and does so precisely. So just get it to where it's sticking out just barely. That's all you want. You don't need it sticking out very far at all. Just like I said, 0.5 millimeter, super tiny. So get it just out, just a hair, and that'll be good. When you go to insert it into your amplifier, there's a lever on the side right here. You need to make sure it is flipped up towards the letters and numbers. That way you can't insert into the 2 holes on the side here. And you just want to press them in until they bottom out. You don't want to try and force them. So when you're looking at it, when you insert it, they do not actually reach all the way into, or this connector doesn't actually bottom out into the bigger portion. So once you insert them, they actually only insert part way here. So once you've got it inserted, put that little gray lever back down. That'll lock them in place. Typically, once you're locked in place, if you're starting to pull on those cables too much, those tips will stay in there and the cable will pull out of them. Mounting them anywhere that's not one of our standard mounts is going to be up to you guys typically. So you can mount it on any flat surface. So if you have like an L bracket that can point where you need it to point, it works pretty well there. J&L hardware is great for that. You can bend it and twist it and stuff fairly easily and still drill a hole that's the right size for this. So having some spare J&L hardware is pretty useful for fiber optic stuff. I like to take some with me if I'm going to go to fiber optics assessment or anything involving fiber optics. Another thing I've seen a lot of people do on assessments is take a pull noodle with them. You can poke a hole in that pretty easily. and kind of wedge that in a lot of different places to simulate what they would need in the end. So, but once you find where you need to mount it, you're going to have two washers, two spring tube washers and two nuts that come with it. Tighten those down around either side. Use a tool to tighten them down so they don't vibrate off. You just don't want to go more than 0.78 Newton meters, which is pretty light. So just tighten them up just enough that you know it's not going to loosen up on its own. If you tighten too much, you will separate that sensing head from itself, and that's not good, right? Actually using it and changing how it functions is pretty easy. So tuning fiber optics, at least stealth fiber optics, is straightforward, pretty simple stuff here. So tuning it is the first thing we'll talk about. That's typically the first thing you're going to need to do once you get everything mounted and secured, is tuning it. And what tuning is going to do is set that threshold level that causes a reaction. So again, essentially what you're doing is setting how far can that fiber optic be before it causes a reaction, before it causes that switch closure. We've got two methods we'll talk about, automatic and minute. We always recommend to start with automatic. It gets you there instantly or almost instantly, and then minute can be reserved for fine-tuning it, right? So starting with automatic tuning is where we always recommend. It's pretty easy. You're gonna turn it on, press the tune button once, and cover the beam. Then uncover the beam, press the tune button again, and you're done. That's all it takes. The larger of the two light levels will be used as your incident light level threshold. So what's cool about it too is you can either start with it covered or start with it uncovered. It doesn't matter which one you do first. As long as you do one uncovered, press the button again and uncover. So a little bit of a video here. So I'm going to press the button with it uncovered. I'm going to press it again and cover. This time it's going to say okay. And now I'm at 700, where I started, I think it was in the 5,000s. So I need to be a lot closer now, so, or farther away, sorry. So minute tuning is our other option. Minute tuning is going to be done with a plus and minus button. So if you notice, I went with the tune button on automatic tuning, I went from 5,000 down to 700 in a couple seconds, right? Where the plus and minus, you're changing numbers one digit at a time. So if I was to try to do that with just plus and minus, it would take a while. But plus is going to increase your threshold. So that's going to mean you have to be closer to the sensor to cause a reaction. So as you increase the threshold, it needs to see more light reflected into it to cause a reaction, which means you have to bring that sensing object closer. Minus is going to decrease it, which makes your number smaller, which means you have to come out, you can come out farther to cause a reaction. So minute tuning again, it's just going to be plus and minus. We started at 5,000 here. This is very, very little change by going down to 4965. And where we're seeing this reaction again is just to the left of the green numbers. You get an out light. That's what we always want to watch for. So light, whoa. Here we go. Light on, dark on. Again, this is one of them you have to cover the beam, one of them you have to uncover the beam to cause that reaction. So light on, dark on is going to be indicated right here above your green numbers, yeah, above your green numbers with either an L for light on or D for dark on. So light on, you must cover the beam, what we have here on the top left. So to cover it, and when you cover it, that's what would, for example, if we're using it as mode, when you cover it, that's what mode is. You cover the thing, and now you get a mode change on your chair. So very, very similar to how a normal switch functions, a normal mechanical switch would function. dark on, you switch that. So dark on is every time you release it, it causes that same reaction. So if you cover it, it breaks that command. So most of the time what I see dark on used for is sip and puff applications. And a sip and puff, it would mount to the sip and puff straw and be pointed at, say, a chin. And then you can set that to be some sort of safety switch or emergency stop, right? So if they ever lose the straw and it's no longer pointed at their chin, it will press that switch, causing the chair to go into that emergency stop function. This one's going to be done by just pressing this triangle button. It's going to be an LD button. So right now I cover it, I get our out light, press the light or the triangle, and I'm always out unless I cover it. So notice here above the green, we're changing between L and D. To reset the settings, so let's say we've been playing with it and it's just not working right, we want to start all over from scratch. You can reset everything inside of here. So resetting the settings is fairly straightforward. It does take a couple of commands though. So you're going to start with your tune button. You're going to press and hold the tune and the LD button both for 3 seconds. After 3 seconds, your LEDs, or sorry, your display will change. You'll get a reset. You have to select with your plus and minus, press your mode button again, and find reset in it, and plus and minus again. So I'm not trying to get you guys to memorize how to do these steps today. When you watch the video, it's a little more confusing than even how I just said it. What I want you to know is that you can reset these features. The instructions are very clearly laid out in the user manual. So you can press it both. You'll get reset over here. Mode button until you get a reset, and plus and minus till you get reset in it. Mode button again, and it does its thing. So we went from 2007 on our light level to 55, which is how we receive it at stealth. And this is in the best video I got out of this, and it still looks like I was a little confused. So locking the buttons is another easy feature that we can do. So we've got everything set perfectly, but we don't want to run the risk of, say, something bumps into those buttons. Maybe they hung a bag near this amplifier and it bumps into the buttons and changes something. Or I've got a 6-year-old daughter at home who really likes shiny things. She sees those shiny lights and buttons near them, chances are she's going to start pushing buttons, right? We don't want that to happen, because then it might change them from light on to dark on, and that could be a big problem. So we can lock the buttons. This time it's a little less complicated. You're going to press your mode and plus or minus at the same time. You're going to hold those two for 3 seconds, and then you get a lock on your display here. Then every time you touch a button, it's just going to say lock on and nothing changes. To change it, you have to do the exact same thing. So mode and plus or minus for another 3 seconds, and you get lock off. And now you can start changing it again. So mode and plus and minus, lock on. So now if I hit a button, nothing changes. So I have to do a plus or minus and mode again for 3 seconds, lock off, and now I can start making changes. And that is it on fiber optics. So like I said, hopefully it's a little less intimidating than you guys were thinking before we came in today. They're pretty straightforward. These things were built and designed for like assembly line sorting in big warehouse manufacturing facilities. So what we do with it is pretty simplified for what they can do. There's a lot of other things they can do, but we never even get close to tapping into that. So hopefully this answered your questions, made it a little easier, less concerning to deal with. If you still have questions, definitely shoot me an email, call me up. I'll try to have an answer for you. So that's all I got for you today, though.
Great, thanks, Ryan.
You guys, yep, no problem. Take it easy out there, guys.